This is for Year 12 Specialists. It comes out of 7b, question 2, trying to solve these definite integrals, and I'm going to be using the inverse circular function rules. In 2d, I've got 6 over 25 plus x squared. I'm going to be using this rule. So a is going to be, a squared's 25, therefore a is going to be 5. So I'm going to put the 6 out the front. I've got 5 squared plus x squared, and I need a 5 there because a has to be at the top. Therefore, I need to multiply by 1/5 out the front to counterbalance. The 5s would cancel, leaving the 6 as being the multiplier from 0 to 5 dx. Now it's in this form, so it's going to equal 6 on 5, the inverse tan of x over a, which is 5, from 0 to 5. 6 over 5, the inverse tan, put the 5 in first, that gives me 1, minus the inverse tan, putting 0 in, that gives me 0. 6 over 5, the inverse tan of 1 is pi on 4, because the tan of pi on 4 equals 1. Therefore, the inverse tan of 1 will give me pi on 4. Minus 0, so I end up with 6 on 5 times pi on 4, which equals 2, 3 pi on 10 is going to be the first answer. Okay, so now looking at 2h. I've got 1 over the square root, so I'm going to be using this rule here, since I have 1 over and it's a positive 1. A is going to be 3 squared. So I have to be a little bit careful here, because if I make the x component, the bit component, so if I go the integral from 0 to 3 root 2 on 4 of 1 over the square root of 3 squared minus 2x all squared, the derivative of 2x all squared is 2 dx. Therefore, I've got a dx, but I need a 2, therefore I have a half out the front. Now I'll go through that again. The derivative of x is dx, but since I have 2x here instead of the x position, therefore the derivative of 2x is going to be 2 dx. Therefore I need a half out the front. So I've got a half. I'm going to have the inverse sign of 2x over 3 from 0 to 3 root 2 on 4. The reason I got 2x, because in this position here, I've actually got 2x. What happened with that 2 is it was the derivative of 2x. So that's going to equal a half, the inverse sign of 2/3 times 3 root 2 on 4 minus the inverse sign of 0. 2 goes into that once, 2 goes into that twice, 3 goes into that once, 3 goes into that once. I've got root 2 on 2. So I've got a half, the inverse sign of root 2 on 2 minus a half times nothing. And I've got a half of the inverse sign of root 2 on 2 is pi on 4, which gives me an answer of pi on 8.